Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on triangles. Previously we saw many theorems such as, if you recall theorems, in one theorem you remember, if you are given that these two angles in a triangle, if any two angles are equal, then their opposite sides, for example this, the opposite side for this angle is this and opposite side for this angle is this, both must be equal in length. And vice versa, if you see, if you are given with a triangle having two sides having, so two sides equal, suppose this, and their respective opposite angles must be equal. For example, for this side the opposite angle is this, okay, and for this side the opposite angle is this, and both of these angles must be equal. I hope this was clear to you. So let's jump right into our examples. Okay, let's jump. So let's see our first example. It says, prove that measure of each angle of an equilateral triangle is 60 degree. Okay, that means if you are given with an equilateral triangle, then you have to prove that all of these interior angles are equal to 60 degree. Okay, so this is 60 degree, this is also 60 degree, and this is also 60 degree. So let's see. So we are using the theorem I just recalled you. So if my triangle ABC is given and it is an equilateral triangle, for example here, that in equilateral triangles all sides must be same in length. Okay, so here AB is equals to BC and BC is equals to AC and AC equal to AB. I hope this is clear to you. So AB length is equals to BC length, which is also equals to AC length. Okay, now if you recall that two of the same length side, then their opposite angles must be equal to each other. For example, the opposite angle to this side is this, and for opposite to AB the angle is this, and from this I can know, or from the theorem we discussed in the previous class, I can say that angle B is equal to angle C. Okay, and if you see these two lengths, then I can easily say that angle A is equal to angle B. I hope this is clear. And from this, angle A equal to angle angle B, which is also equals to angle C. I hope this is all clear. Okay, we just use the previous theorem. Okay, so angles opposite to equal sides are equal. I hope you get this point. Okay, yes, it is given. Now what? Now how we are going to say that angle A, angle B and angle C are equal to 60 degree. So if you recall, the in triangle interior angle sum, all the interior angle, if you add them you will get 180 degree. That means if you have any triangle, then the angle here, angle here and angle here all add up to equal to 180 degree. I hope this is clear. And from this I can say that angle A plus angle B plus angle C is equals to 180 degree, which implies And I also know that angle B is equals to angle A, angle C also equals to angle A. Then I know that 3 times angle A is equals to 180 degree. Because reason is this, because all of the angles are equal to each other. Uh, from this I can rewrite it as angle A is equals to 60 degree, and because angle A is 60 degree, then I am going to use this again and say that angle B and angle C are also of 60 degrees. I hope this is clear to you. Let's move next. Here, if D is the midpoint of hypotenuse AC, if you draw a right angle triangle, say this. Okay, here is my right angle triangle. A, B, C, and D is the midpoint of AC. Here is my D, and from this I can say AD, the length of AD must be equal to the length of DC. Okay, I hope this is clear, because D is my midpoint, so AD is equals to DC. Okay, now angle B is of 90 degree, as it is already given. Prove that the BD, so this line, the BD, this line BD is equals to, so we have to prove that BD is equals to half of AC, that half of the hypotenuse. Okay, I hope this is all clear to you. Let's see step by step how we are going to prove that. So in all of these we are given lots of information, and let's make a rough diagram for that. So we are given with this, the A, B and C, D as my midpoint, D, this AD is equals to DC. And here if you construct something, what I am going to construct, just see, just produce this BD to E. So BD, we produce BD to E, say E, okay, and now join E and C, okay. We produce BD in such a way such that this BD is equals to DE. Okay, so by construction, BD is equals to DE. We have produced in such a manner that we will get BD is equals to DE. Okay, now what? If you try to see in two triangles, what two triangles I am talking about? The triangle ADB. So if you see the triangle ADB, ADB, so triangle ADB, okay, this and this, and another triangle, the other triangle is what? CDE. So CDE, this triangle I am talking about. So this is this. So CDE. So if you see in both of the two triangles, you know this side is equals to this side, and this side BD, say here was my D, the BD is equals to DE. Okay, now if you recall that if you have two if you have one intersection, and from this we know that vertical opposite angles are equal to each other, that means this angle is equal to this angle. So as you can see here, we have an intersection. So from this I can say the angle ADB is equals to angle CDE. Okay, I hope this is clear, because of the opposite, vertical opposite angles are equal, vertical opposite angles are equal. Okay, so we have AD is equals to DC, we have BD is equals to DE, and ADB is equals to angle CDE, because vertical opposite angles are equal. Now using what I am going to use, if you see side angle side, I can say that both of my triangles, triangle ADB and triangle CDE, are congruent to each other. Okay, I hope this is all clear. So my both of the triangles are equal to each other. Okay. Okay. So my this triangle is congruent to this triangle over here. Okay. So from this I can easily say that this length is equals to this length. I already know by construction this is already true. And if you see that this remaining side also be equals to the remaining side in the other triangle. So this means AB is equals to EC by CPCTC. CPCTC corresponding part of congruent triangles are congruent. And we already know this angle is equals to this. Why? Because of the vertical opposite angles. And then the angle made by this side, the first and the third stake, is equals to here the first and the third stake. Okay. So angle over here, and the remaining angle is equals to the remaining angle over uh, in the second triangle. I hope this is all clear. Okay. Now, if you see what you will see that you have this much of information from this. Okay. Now let's move. Okay. So by CPCTC, CED is equals to ABD. So this means you know this, we have A, B, C, this D point and this E point. So CED is equals to ABD. I hope this is all clear. I have already told you. Okay, now let's jump. This means that if you again construct, what you will get is this that this angles, this was our D, A, B, C, E. Okay, this angle is equals to this, and this angle was equals to this angle. Okay, so and these two are all equals. Okay. Okay. Now what? Now if you see that CE is parallel to AB, so where is my CE? So this CE is parallel to AB. This means, if you see, this means the angle ABC, the angle ABC, this angle plus this angle ABC, angle ABC plus angle ECB, this angle, okay, must be ECB must be 180 degree. Okay, because of the consecutive interior angles. Okay, now, and we already know what we already know, that this ABC, this angle this whole angle was my ABC. Okay, so this ABC, so this angle ABC we are talking about. Okay, so this angle ABC, which was of my 90 degree, so 90 degree, and this angle ECB I am talking about this angle. Sorry for the error. Okay, slip of tongue. Okay, so this and this angle I am talking about, the angle ABC and the angle ECB, this angle ECB. Okay, so this equals to 180 degree, and this means the angle ECB is of 90 degrees. So this means this is my angle also 90 degree. Okay, I hope this is all clear. Okay, now what? I have this and this both of angle equals to 90 degree. Okay, now if you see that in triangle ABC and ECB, we have AB is equals to, if you again see, so this is my diagram. So in this diagram, A, B, C, D and E. Now I know this is of both 90°, then AB is equals to EC. Yes, AB was equals to EC. BC is already common. Okay, we are talking about these two triangles. Okay, and the angle is this angle, the ABC, and angle ECB is of both 90° angle. So this means if you say that angle side from, okay, so angle side, or the the, if you see this side angle, okay, side angle side, okay, side angle side. So this was our BC was common. So side angle side, from using side angle side, I can say what I can say, that the both of my triangles were congruent. So this means this. So by CPCT I can easily say that AC is equals in length to EB, and from this I can say half of AC is equals to half of EB. Okay, and EB, if you recall, let me draw again. So here was my E, here was my B, here was D. So EB, if you recall, EB is equals to BD plus DE. Okay, so I'm just replacing this EB as BD plus DE. Okay, and I know that BD plus DE, this is or equal in length. So this means I already know that BD is equals to ED. This means I am going to rewrite BD as just untouched and DE as BD. So this means EB is equals to twice of BD. So from this I can rewrite half of twice of BD, and this two get cancelled. Then I will just have this BD remaining. So BD is equals to half AC. I hope the proof is clear to you. Okay. Sorry for the little slip of tongues. Okay. I hope you did not got confused. Okay. So let's move to next. In next example, in a right angle triangle, one acute angle is double. So we have a right angle triangle. So let's draw a rough diagram for it. So right angle triangle. Okay. And one acute angle is double. Acute angle is less than 90, if you recall. So if you say, if this is my one of the acute angle, then let it equals to x, then other one is 2x. So other one is double the other, which is 2x. Prove that the hypotenuse is double the smallest side. Okay, so we have to prove the hypotenuse is double the smallest side. So let's see that how we are going to approve, how we are going to approach it. Okay, let's see. So here we are letting that triangle ABC is my right angle triangle with angle B is of 90 degrees. So this means this is my triangle. This is my A, B and C. Okay, I hope this is clear, and this AC is my hypotenuse. Okay, I hope this is clear. Okay, now let's see that in triangle ABD. So we are going to do some construction. So what construction? So just produce CB to D. So let me produce a CB to D. So here is my D, and now just join A. Okay, now what? Now the construction is such a manner that BD is equals to so this length must be equal to this length. That means DB or BD is equals to BC or CB. I hope this is clear. So if you see in both of the two triangles, the triangle ABD, this triangle ABD, and triangle ABC, this second triangle ABC. So if you see that BD and BC are equal in length because of the construction. So this is equals to this. AB is common, so this is already common, and this angle is common. So side angle side, using side angle side, I can say that these both of the triangle we took are congruent. Okay, now what? Now we know that both of my triangles are congruent to each other. Okay, now if you see, so A, B, C. Okay, so now what? This length is equals to this, and this was already the common length, and from this I can say the remaining length must be equals to the remaining length in another triangle. Okay, from this I can say AD is equals to AC. Yes, now if you see, by corresponding part of congruent triangles are congruent, I can say angle DAB. So angle DAB, this angle must be equal to angle CAB. So angle CAB, so this angle. Okay, now I am taking the, because AD is equals to AC and angle DAB is equals to DAB is equals to X. So I am letting this angles to be X. So this means this is also be my equals to X because both are equal. Okay, now what information I have got, and also this is of my 2x if you recall. Okay, okay, now what? Now let's see that this is also of 2x if you recall. Why? Because of the corresponding part of congruent triangles. Okay, so here this is also of my 90 degree. Okay, I hope this is all clear. So let's move to next. Now how we are going to, so this is my diagram. Okay, now what? So if you recall the diagram, in diagram we know this is of my 90 degree, this is ABC, this was my produced extra BC produced to D, and this is X, this is also X, and DAC, this angle DAC. Now if you see this DAC angle, this whole angle or the angle over here, what is it? It is X plus X, which is 2X. So this is 2X, and angle DAC is equals to angle ACD. So DAC is equals to ACD. So this angle over here, this was also 2x if you recall. So this is also 2x if you recall. Now what? Now if you see that this is of my 2x, this is also 2x. If you recall that in triangle, if two angles are equal, for example here and here, then their opposite uh, sides also must be equal in length. So from this I can say the opposite side to this is just whole DC. So this DC must be equal in the opposite to this, which is AD. So DC is equals to AD as written over here. I hope this is all clear. So from this I can say, as you recall, the side opposite to equal angles are equal. Okay, now what? Okay, so from this this was my B, D, A, C is to X, just X, 90 degree. Okay, here if you see that from this I can say that twice of BC is equals to AD. Why? Because if you see twice of BC, because BC plus DB is equals to what? DC, which is whole, this DC, and we know DC is equals to AD. Okay, just previously shown. And from this I know that this DB is equal in length, this DB is equal in length to BC. We know DB is equals to BC. So from here I can rewrite things. So BC plus DB is also BC is equals to AD, and from this I can rewrite as twice of BC is equals to AD. Okay, twice of BC is equals to AD, and we know this length is equals to this length because by the CP/CTC. Okay, so this AD is also equals to AC. So from this I can give you the final result, which was this, and this was the thing we had to prove. Okay, so AC is equals to twice of BC, where BC is my smallest. This was my smallest side. If you recall why I am saying this is my smallest side, in triangle, if you recall that in right angle triangle, this is my hypotenuse, this is my biggest side. Okay, and if you recall, the longer the angle, okay, suppose this is my larger angle, okay, than this angle, then my larger side will be, in compared to this side, is this. Okay, for example, if you draw a triangle, say here, if you construct this is my, say, uh, the 90-degree, then this is my longest side. Yes, this is my longest side. Then if you recall that this is my longest side in the triangle, and here is, say, just 60-degree, and here if you say is say as sorry, here is 60, here is 30-degree. Okay, then if you compare these two lengths, okay, if you compare these two sides in length, then you will get this, that this side is bigger, this side is bigger than the side here. Okay, why? So there is a theorem on which, in which the theorem says that if you have a larger angle, say here, then the opposite side to that angle is the longest side. So if you compare, here is my the largest angle 90, and the opposite to that side was hypotenuse, and in reality the hypotenuse is the longest side. If you compare for this 60 and 30, you will get the largest side will get to the angle which is bigger. Okay, and the smallest side will be where you get the acute or the smallest angle, you say. Okay, so in here the angle is just x, then the smallest side, in if you compare to this and this, you will get this is the smallest. Okay, so BC is my smallest, so twice of BC, or AC, or my hypotenuse is double the smallest side, the smallest side. Okay, I hope this was clear. Okay, let's see for this. If you now let's some inequality relationship you must remember. So in triangle, if two sides of a triangle are unequal, then the longer side has greater opposite to it. So this was I am talking about. So if two sides of triangle are unequal, then the longer side has greater angle opposite to it. This means if you have, this is 5 unit, this is a 10 unit, and say this is say just something you want to say, so 5, say 4, say 3. Okay, so in here, so which one is my say the two sides of triangle are unequal, so here and here are two sides with unequal. Okay, and then the longer side has greater opposite angle, so the longer side is this one, fifth one, the opposite angle is this. This means this is greater angle than the angle opposite to this side, which is this, then this angle. Okay, I hope this is all clear from this. Okay, so in a triangle ABC, if you are saying AB is greater than AC, so triangle ABC, ABC, if AB, so this AB, the red side is greater than AC, then the angle which is bigger is angle C. So this is bigger than the angle over here. So this angle is bigger. Okay, I hope this is clear. In second point, in a triangle, the greater angle has the longer side opposite to it. Okay, so if you have a triangle, then the greater angle, so whichever angle is the greater, the opposite side must be the longer side. Okay, and in triangle, the sum of any two sides, so if you have a triangle, then if you sum any two sides, the sum must be greater than the third one. So AB plus BC must be greater than AC, BC plus CA must be greater than AB, and AC plus AB must be greater than BC. That means any sum of any two sides must be greater than the remaining side. I hope this is all clear. The fourth point is, if you draw a line segment that cannot if you draw a line segment, okay, if and you are given a line, so this is my line, this is my line, and if you draw a line segment not from a point P which is not on the line, so here is my line segment, for example this, so from this the perpendicular line segment is the shortest. This means, so if you have to find out the smallest line segment to this point to the line, then you will get that the shortest length or the shortest line segment will be perpendicular to the line. Okay, I hope this is also clear. For example, this we have given a line and a point not on the line, not on the line, and the shortest, so this is my shortest line segment. Okay, shortest line segment from P to the point on L, on the line or the L. Okay, so if this is the shortest, this means the angle here must be equals to 90 degree. I hope this is all clear. Okay, so I hope this is all clear. So the final point is that if you already saw, the sum of any two sides must be greater than the remaining side, and here is the difference of any two side must be less than the third side. So in triangle, if you see in triangle ABC, say this, if you if you subtract two sides, for example this AC to AB, okay, AC to AB, then this is must be less than the remaining side, which is CB or BC. I hope this is all clear. Okay, okay, so in say in triangle ABC, I hope this is all clear. So I hope you understood all these little inequalities and all of the exercise or the examples and their approaches. Okay, and how we used the previous theorem, how we connected our theory to question solving. I hope you understood them very well. So thank you for your attention. We will meet again next time. Okay, so thank you.